All right, so these are the due dates. So 2 things due on that one day. All right, so let's, one of the things that I should have done earlier is talked about how to input data. So if you look at these assignments that we're working on, you need to write code that prompts the user for something. So ask the user to enter in some information. So I don't think that I covered that.
No.
So I wanted to talk about that. And you'll notice here that I moved this, this reading material up into the second meeting time. And this shows how to prompt the user to do things. So we print out, enter an integer. We declare an integer, and then we read an integer in from the keyboard. So that's how you do it. It's pretty straightforward. So this is a pretty good summary of everything you need for this course to do the problems in this course. Actually, you don't even need this last one here. I don't think we use that. If you're on Windows and you're using Visual Studio, you might need to use this here. Because in Visual Studio, the console window will very briefly display and then get shut down right away. So we want to pause it. So this call see and get just asks the system to get the next keystroke from the keyboard. So it's called a blocking call. So it waits. So it keeps the console window open. So that's just for Visual Studio. If you're using it. All right, so what about this code here? There it is. So here's from the web page. It shows how to prompt the user for an integer. Enter an integer, we print that, declare an integer, and then read it in. Well, I think we must be in SAM. No, we're inside there it is. So enter an integer, 3. Enter a floating point number, 2.2. Enter a line with spaces between words. And let me try that again. And that's not working. So this is get line. So I don't see why that completes so quickly. Oh, I know why. This isn't going to work. Watch this. The problem is, let me explain this to you. See, when I run the program now, and I press 5 for this prompt, at this point, we're at this point in the code. This operation is executing. And there's this buffer. You can think of it as a list of items that need to come in from the standard input stream, or the console, or rather the keyboard. So 5 is in this buffer right now, waiting to come in. And when I hit return, what happens is this operation pulls the 5 out of the standard input stream, but it leaves the new line event in there. And then when we output this, and then we read in the next value, we read through the new line, and then read the next value. But now, these numbers are like pending. They haven't gone into X yet. Now, when I hit the return key, this input operation here will pull 66543 out of the input stream, but it will leave the new line character, I'll say, in the input stream. So then when we get to the next line here, the next input operation, the get line sees a new line character in the input stream, and it says, oh, it must be an empty line. So then we terminate. So my example is, it's got a bad example, it's not a good example. So what we need to do is clear the input stream. I think there's a clear operation. One way to do it, of course, is just to get the new line that's sitting in there and discard it. So that, that would be a new line character. So we can get the new line character and then just discard it. And then this get line will wait for us to, it won't encounter a new line right away when it executes. Let's see if my theory is correct. It looks like it works. So that's how to do it. Now there might be another way to clear that input stream. I'm going to try another way. I think there's like a clear operation. Something like that. I wonder if that'll work. I'm just guessing. Let's see if it works. It compiles. That doesn't work. This clear operation does something else. It doesn't clear the contents of the stream. It clears these flags that tell it whether it's in that indicate whether the stream is in an inconsistent state or is in a failed state. I'll show you how that works. I'm going to put a comment in here. You know what? Before I forget, I got to do this. All right, so I have it in there. I'll show you another problem with this code. Let's suppose we run this again. And I'm asking for an integer, but I'll type in something that's not an integer. And the program terminates. Because here, this operation, that input stream goes into an error state. So it's in what's called a state. Either things are running normally, or things are running abnormally. So now it asks for an integer. It's expecting an integer. It's trying to execute this input operation and convert to an integer, but it can't convert RTY to an integer. So the stream just sort of has a nervous breakdown. It just says, I can't do this anymore. And so the next time we try this operation will return immediately. Actually, it runs line 10 because you see it right there. See that? And then this operation will not, because the input stream is in a failed state or an error state, let's call it an error state, that this operation returns immediately. Nothing gets stored into X. So the contents of X would be random at that point. And then when we read from the keyboard, once again, we can't call get on this input stream because it's in an error state. So that call returns immediately without doing anything. New line char is probably not initialized. It may be initialized to 0, something like that. And then we call get line, and the same thing happens. Of course, you'll see line 16 runs. Line 16 runs. There it is. So if you want to so we can check for that. If cin dot, I think it's good, that's one way to do it. If it's not good, so if cin dot good, if that returns false, that it's not, the input stream is not good, then let's see if that's what happens. And we'll return here. Let's see if that does the job. Cin is not good. So we could do something like this. Have we covered loops yet? No. We have not yet covered loops. So we're going to cover that later. So instead of returning here, let's do this. Let's call clear. I think that clears it, resets the state of the input stream. Let's see if that does the trick. Thanks. RTY still doesn't work. How do you clear the input stream? Does anyone know? Is it reset? I'm guessing. Yeah, it's fun to guess, huh? What's the word? Clear. Reset.
Could it be C in return?
Huh?
Could it be C in return? Return 0 instead of it being return 0.
No. I want to continue executing this code down here. So I want this operation. Right now, this operation is it's executing, but it doesn't do anything. It doesn't read anything into X. How do I reset the input stream? Like they're trying to do this. Look at that. Oh, we have to pass the value in. Set the error state flags. Let's take a look at an example. If state is good bit, which is 0, all error flags are cleared. So we're going to pass in good bit. Is that what we have to do? I'm not reading the whole thing there. I'm just going to do this quickly. This may not compile. Maybe it will. Let's see. Oh. Close that thing. Lost it. Clear good bit. Move a little slower. Good bit was not declared. Good bit is in, oh, there it is. I think it's iOS. I saw it up here. See it? iOS : clear. Believe it. So that's so good bit must be a member of a class. So RTY, I'm still not getting it. But you know what? I don't want to stay hung up on this. I'll play with this later and then show you later this. But this is a side excursion we're doing here. There's nothing in the problem sets I gave you or the exams I'll give you that require knowledge of this. But you might need to learn this at some point. So that's why I'm presenting on it. All right. We could keep going on that if you want me to give up. Anybody want to see the end of that?
So
I better not quit too early here. Yeah, go ahead. What was that?
So what's exactly the issue?
See, that's the thing. It's hard to follow what the issue is, isn't it? So this,
You're trying to make it start over?
yeah, I'm trying to reset the input stream to so that
Without a loop?
so that the subsequent input operations don't fail automatically. It's hard to see what's going on unless you're working on it yourself.
We can't use a loop?
Well, I mean, we should figure out how to get this to work first, and then we can put it inside of a loop. Because it shows it here, it's just clear. This is the fail bit is set. We call clear to remove the flag and allow further operations. So I don't get it. Why, I should just be able to call clear here. And have it complete. But you know what? I better not waste time on that. I'll work on it later. Okay. What else? Anybody stuck on any of these problems and you want to talk about this? Yeah.
I'm stuck on the second one. It keeps reading two numbers or two statements from me. It keeps displaying good number and bad number.
Can we look at your workspace?
I just have a question.
Yeah.
On the first one, for the first exercise, it says.
Wait. Let me get this other one first. Can you give me the few letters.
SHD.
That one?
Yeah.
Okay. Well, hold it, that question, okay, we'll get right to it. All right. Well, I gotta say, one space for indentation is kind of deficient. It's not enough, I would say. But it's nice to see that you're indenting, although this indent is inconsistent. See, this one here, you've got two spaces at your second level, but your first level, you have one space. It's a little hard to read. It's not, I think I would go at a minimum of 3. That's what I see in practice normally, or 2 if the code has a lot of indentation in it, like JavaScript. So anyway, we'll work with it the way it is. Enter a number between 3 and 12. So that's the prompt. And then we input the value. And that looks all right. And if x is greater than or equal to 3, and that's a bitwise and. So you want that to be double ampersand. Can you fix that? Just watch. Let's everybody watch that. See, that's bitwise and. It should be logical and. That's a logical and. That's what we want. There is logical and. Bitwise and means each bit in the left-hand side and right-hand side, bit by bit, the 1 and the 0 are anded together. So 1 and 1 is 1, 1 and 0 is 0, 0 and 1 is 0, 0 and 0 is 0. So instead of doing a bitwise and, we want to do a logical and. So we consider the whole left-hand side, is the whole thing true or is the whole thing false? And the right-hand side is the whole thing true, without looking at the individual bits. Try it now. Well, why does it say good number and bad number?
Your second if statement is triggers if x is less than 2 or if it's less than 13.
Well, I got to see there's an issue here. You have a semicolon right there.
When I compiled it the first time, it said I had to do it, and it wouldn't compile if I didn't know what that was about. So I just put it there, and then it wouldn't compile.
No, it's not. Does not belong there.
I thought that.
Because that will. You can leave it there for now. Leave it there for now. Now, wait a minute. That expression, if x is less than 2 and x is greater than 13, what number is less than 2 and bigger than 13? Give me a number that's less than 2 and bigger. There's no such number, right? So that's a logical fallacy. Is that what they call it?
Yeah.
The opposite of a tautology?
So what would I write instead of that?
You can say or.
Just write or?
No, well, the upper symbol, that's the bar that goes up and down.
I don't know which one it means.
It's above the slash,
It's
near the return key.
this button. Oh, that was the slash. That.
Yeah, two of them. That's logical or. That's if x is less than 2 or x is greater than 13. It still won't work, but let's try. It should work, right? But it won't work because of that semicolon. Well, let's see it run. See, it's still the same problem there, right? So you've got to get rid of that semicolon. See, that semicolon makes this semicolon inserted a blank statement as the body of the if statement. So the curly braces that followed it were not connected to the if statement at all.
Okay.
This will work. Let's try it. Let's test it now. Now it's working. Let's try, yeah, like 14 or something. Yeah, good. Now it's working. Can you clean up the indentation and the spacing a bit? I just want to see, we want to make this a complete, like this has got too many spaces. That's 2 spaces. Should only be 1 space, right, to be consistent. Yeah, can you add more spaces? I think 1 space is not enough. Yeah. Yeah, do the whole file. I want everyone to look at this. Let's clean up the whole file. Let's use 3 spaces for all indents. Keep going, keep cleaning. Every indent should be 3 spaces. Now that C out after inside the if statement, that should be indented 3 spaces, not just 1. Yeah, there you go, in there. There you go. Oh, that's 4. That's 4. I can see my eyes. There we go. And then you got too many spaces here. This is not, you've got 2 spaces there and 1 space there. That's an inconsistency. That should be removed. The same with this area up there. And then, and look, you've got a space in front of good, but no space in front of bad. So why would that be? That must be just sloppiness, right? Of course, please is spelled wrong. We got to clean that up. There we go. Now, the only inconsistency I can see now is that this, you've got a space here. And in no other case, like, I guess you could say that's what I'm going to do, but you don't have any space between the scene and the output and the input operator. It's a bit tight, but it's not too bad. But I would say that this space you have in here is a bit inconsistent with the rest of your code. So you're not using spaces. So you're using this operation here without any spaces around it. But you use, in this one case, you're using a space. So do you want to use spaces or do you want to have no spaces? No spaces. Tighten it up like that. Now I would say that this is pretty consistent. Let's check it and see if it builds and runs. And so I want everyone to be very careful to format your code neatly like this. Okay? And the most important thing to pay attention to is the indentation. Without indentation, it's hard to catch logical errors. Did that run correctly? Okay. And the next question was a question on, you had a question?
Oh, I just wanted to understand. When you said the sign of x and y, did you mean like the sign of the average or the sign of x? The average?
You're talking about exercise 1?
Yes.
The sign of the average of x and y.
Okay, so find the average and then do the sign of the average?
Yeah,
Okay,
take the
so-
sign of the average. What's the average of x and y? Does everybody know that? Yeah, x plus y divided by 2. So after you do that calculation, then take the sign of it. All right, any other questions on these problems? Oh, this one, right? Do you know how to do this one? This modulo operator? That's the remainder operator.
I actually have a question about that one.
Yeah,
You want me to pull up mine?
you have a question on
The module one.
that one there?
Yeah, I think I actually have finished, but I wanted to make sure.
Let me talk about that.
Okay.
So if I take 5 and divide by 2, what do I get? What gets printed here? Anybody know? 2. Of course, if I do this, then I get something different, right? 2.5. Because this is now floating point division. This is integer division. So what I want to talk about is integer division. Like here, there's a remainder. When you take 5, you take 2 2s out of 5, and you have left over 1, right? So the remainder, we can calculate the remainder. It's 5% or mod 2, 5 mod 2. This is just a remainder operator. It's kind of the complement of integer division. This gives us the, how many whole units that we take out of the numerator. And these are how many whole units are left after we remove that many from the denominator. I'm sorry, from the numerator. Five, 2 and 1, so it's 2 with the remainder of 1. Two, 5 divided by 2 equals 2 with the remainder of 1. What about 10 divided by 7? Make it like 30. 30 divided by 7. What's 30 divided by 7? What will this compute to?
4, right?
4. Is that right? 28. Okay. 4 sevens is 28. So 30 divided by 7 will be 4. And so we're going to end up taking 28 out of 30. So what's the remainder going to be? 2. Good. So 30 mod 7. That means what's the remainder after dividing by 7? 30 mod 7 will be 2. There it is. So this modulo operator turns out to be pretty useful in computer science. That's why I'm making a big deal about it here. I mean, obviously it's not used like multiplication and division, but it's pretty widely used, and I certainly use it. I use it. And in math, there's a lot of the modulo operator is important in math studies as well. I know. I've been there. So that's that. Oh, enter a number. If the number is even, say it's an even number. If the number is odd, then say the number is odd. So this is the problem. Use the modulo operator to decide whether a number entered by the user is even or odd. So we would need to, oh, there we go. Close that out. You want to do this one? Yeah, I'll let you do it. This is Sheridan, right?
Oh, yeah.
Yeah, you're live. Let's watch you do it. Good, that's it. You got it. You're getting it. So if x mod 2, well, we need a comparison operator in there. If x mod 2 equals something. if the remainder is 1, even if you get a remainder of 1, yeah, odd, yeah. So like, 5 mod 2 is 1. That means 5 is odd. That's good. And then how do we handle the other case?
Should I use that now?
You can just do, the thing is, something mod 2 is only going to be 0 or 1. It can't be anything else. So if you check for, oh, by the way, this should be double equal. This is assignment. That's not, that won't compile. Oh, yeah, that'll compile. That does comparison. That's the comparison operation. That's different than assignment. So you could either say x mod 2 equals 0, or you can just say else. Else see out even number, because x mod 2 can only equal 1 or 0. It can't equal anything else. What other remainder could you possibly get when you divide by 2? 0 and 1 are the only 2 possibilities. So we can simply use an else clause there. Yep, that looks good. We're using VI, that's great. Okay. Did you write?
Yeah, I was.
You sure you hit enter up there? There you go. Oh, E dot. Odd number. Even number. It's good. You got it. Good job on that. Taking over my job up here. Thank you. Appreciate that. So that's that one. And let's see what time it is. Well, I used a lot of time. What about random integers? Do you want to talk about random integers? Okay. Let's talk about random integers. There's a function called rand that prints, or that produces a random integer. Well, let me do it like this. Integer I equals rand. If I call rand, and then I'm going to print I, that's a random integer. Rand was not declared in this scope. Rand is a function, so when we call the function, it's going to evaluate to a value. We're going to store it in I. But it's not defined in this scope because it's in some header file. I think it's in CMath. Is that what I said?
Yeah.
I said CMath, right? Oh no, I said C standard line. C standard line. Let's try that first. It might, I don't know, it's probably available through both headers, but one of them is the required header. I don't know which one that is. So there's a random looking, it's called a pseudo random number generator because it's not truly random. Like if we run the program again, we get the same random number. That's because it's these pseudo-random numbers are being generated. Each time we call rand, it's using the same sort of procedure to compute the sequence of random numbers. Here, let's get a second one, J. See that now we have, they do look random, don't they? But when I run it a second time, I get the same sequence. I get the same two numbers. That's because, like I said, it's a pseudo random number generator, an artificial random number generator. And it's producing the same sequence of values. So if we want a different sequence, we have to seed the random number generator. So srand is the function that you call, passing in some integer, that seeds the random number generator so we get a different value each time we call it, hopefully. So that's our new sequence. Of course, each time we run it, we're passing in the same seed. So we're going to get the same sequence. So we need something, we need to change this value every time we run the program. If we want something that looks more random, if we want the program to behave differently each time we run it, we need to change the seed to the random number generator. And let's pass in the seconds since 1970. So if we can grab from the system the number of seconds that have elapsed since 1970, then we'll use that. Actually, I think that might be a long integer. Pretty sure that's a long. All right, but now it's just 100 here. So how do you get the seconds that have elapsed since the first second of 1970? It's we just call the time function with the value 0. This is a standard epoch in Unix systems, 1970. I don't know why. They picked, there's a reason, maybe not a reason, but they had to pick something. So they used 1970, the beginning of 1970, Greenwich Mean Time as the standard epoch. So now, each time we run this, first I have to compile. Each time we run it, we're passing in a different seed value. See that? Now we're getting a different sequence of random numbers, an apparent sequence, a sequence of apparent random numbers. So that's how to work with random numbers. One other thing you might want to look at there is, well, the numbers are kind of big for our application. We want them to be smaller. We want them to be less than 100. So we use the modulo operator here. We'll take that big random number produced by rand. We'll divide by 100 and take whatever the remainder is. The remainder will be between 0 and 99. So that gives us a nice small random number if that's what we need for our application. See that? So if you need random numbers, there it is. Oh, look at that. Look at this. What happened?
You did it within the span of a second.
Yeah, exactly. Exactly. I ran it too fast. I didn't wait a second. So I got the same second value for this. So that's that one explained out. There's all there in the notes here. And then we have these quiz problems. For this second assignment. How about this one, number 6 down here? Let's take a look at that together. Write a C++ program that prints a random number between 75 and 125. Anybody want to try that live? Any challenge takers out there? I can help walk you through it. Oh, okay. 75 and 125. This is easy. Nobody wants to do it?
I don't have an internet connection on my laptop.
You have it?
Well, I don't have an internet connection on my laptop.
You can't do it? Anybody else?
Wouldn't, if you go back to the one we were just working on, wouldn't you do that, but then instead of modulo 100, would it be modulo 51?
Yeah. Let's take modulo 51. Now this produces a value that's between 0 and 50.
Yeah, so then you do C out 75 plus I.
Plus 25
75, right?
or 75?
Plus 75 and 125.
Yeah. So this will be let me do it like this. Let me keep the I here. Just it's easier to write the comment. I equals I plus 75. And now I is in, let's see, I was originally as low as 0 or as big as 50. Now we're going to add 75, so it's going to be as low as 75 and as big as 125. So it's in that interval. You see how that works? We're adding 75 to I. The smallest I is going to be is 0, so the smallest that the result will be is 75. The largest that I will be is 50, so the largest that result will be 125. 84, 96, 90. So these are all between 75 and 125. 79, that's the lowest we got here. 76. 76, that's pretty low. We're almost at the minimum there. All right, so that's how to do that one. And I think we looked at these last time, didn't we? These down here. Yeah. I think that's probably good enough. Any other questions about this assignment? Yeah, back there, Sheridan.
I was working on the fourth example about the temperature. And I got the same thing when I tried to compile it, where it told me to put a semicolon.
Right here?
Yeah, it told me to put a semicolon right after the.
Well, you can't just go with what it always tells you because it's not really smart enough to tell you what to do, okay? So now we just learned that lesson. If it tells you to put a semicolon somewhere, you got to question it. Question authority.
Well, that's what I questioned it because you said it shouldn't go there.
Huh?
I questioned it because you said it shouldn't go there.
Yeah, right. Does it work now?
No, I compiled it twice and it didn't want to run it.
Let's see. Let's take a look at. Why don't you compile it again, and we'll take a look at the result here. All right, let's read it. Let's look at this. So, in function int main. Whoop. It's saying there's some side effects there. It's not perfect, this program. So, look at these numbers there. See that number? You know what the first 18, that's line 18. Let's turn our line numbers on. I'm going to do that. View. How do I turn line numbers on? How do I turn line numbers on? Anybody know how to turn the line numbers on? There's a way to turn the line numbers on.
Because you're in VI.
Oh, you're in VI. Yeah, so do this. How do you turn line numbers on in VI? How to turn line numbers on? I forgot how to do it. Set number. Let's try, just type in colon set number. Yeah. Space. There we go. So it's saying line 18. So it's just bringing our attention to line 18 here. So that's this one here, right? And it says expected semicolon before the brace. So yeah, you put one in there, right? But that's not how to solve these problems. It's something else. Let's scan it. And you know what? This is not enough space to look at. This is, let me see if I can. I need to see the top up here. How can we do that? Is there any issues up here? Like maybe a quote was left open. Maybe there's a brace that hasn't been closed. When you put the semicolon in there, did it compile?
I didn't put it in yet, I just asked you.
All right, well, I'll tell you what I'm thinking is that I want to check to make sure that the thing that we're compiling down here is what we're looking at. How do we know that that's what we're looking at? It's EX4. It's that one right there, right?
Yeah.
So I double click that. Wait a minute. Did that just open up a different window? Yeah. That opened up a different window, right? Oh, you're in VI.
Yeah.
Son of a gun. So you're in VI. Let's close VI for a second. Just show me that you're in the right folder.
Okay.
Oh, you want a WQ. Oh, maybe you didn't save it before. Yeah, WQ. Let's try to build it now because something wasn't saved.
What's VI?
VI is a very ancient editor, text editor, like, you know, it's a nice tool to use because it's installed everywhere on Unix systems. Let's try to build it now because you saved it, right? Maybe you didn't save it before. It was still the same problem, right? How are we going to solve this problem? Let's do this. Let's quit VI, and I'll take over. Okay. So just go ahead and quit VI. I'm going to open this up in this. Here's a different editor. VI is an alternative to the editor we're using here. This is an editor that's more of a graphical interface. And so one thing that we could do, let's do this. I'll take this whole block of code and I'll comment it out. Because I want to know, you know, maybe the bug is up here somewhere. And so if I comment out this good code, everything should compile. But if everything compiles now, then that means the error must be in this section. So I'm going to save that, and Sheridan, go ahead and compile that again.
Do I open the window viewing?
Just down here, you're going to compile around. Okay. That compiles. See, now that means that this code up here is okay. This is not causing an error. So I'm going to move this down. I'm going to move this down to here. And I'm going to save again. Let's see if that compiles. That compiles too. Okay, let's keep going here. So we're going to try to isolate the bug. Let's see if that compiles. That compiles. I can't believe it. Okay, so if we take this out completely and save, it's going to fail. And we get a failure there. So this is quite the mystery, isn't it? If we cut this out, once again, if I cut this out, let's do this. Let's do this. I'll just cut that one line out there and save it. Let's try to compile now. There's something going on there. I got to say, one of the things that's weird is that, you see the mistake? This should be else if. You have a condition in here. So this should be else if.
I thought it had to go if, else if, and then else.
Well, if you want to do else, then you have to delete that whole thing right there. You can delete that whole block and then just have else by itself. But if you're going to have a condition, then you need to have an if. Which one do you want to do?
Would I just put the if there, or do I?
Yeah, you can do the if you want. And so I should have saw that right away. So let's try that now. Try 30. Oh, that's good. 30 prints cool? How does 30 print cool? Huh?
77.
Oh, actually, this shouldn't work. This expression. Does this expression work now?
No, I think when I tried this, it screwed me up on it too. I guess.
Yeah, so what's not working great? 77 is not cool, right?
No, it should be.
Yeah, let me tell you, this evaluates to true or false. And that becomes the left-hand side of the next comparison. So it's true, which is probably, the system is probably using the value of 1. So 1 less than or equal to 60. You see, it's compiling, it's not, in another language, the compiler will fail to compile this code, but in C++, it'll accept this. That's a weakness of this language, by the way. It's because it's an old language and it's required to work with C. So you have to split this out. This should be 40 less than x and x less than or equal to 60. So you need to use and in there. Yeah, good. That's what you have to do. The same with the other ones. That one's okay. Let's try it now. Still says cool. Why does it say cool?
Did you save it?
Oh, we got to save it.
I don't know how to do that on this format.
I'm going to do the file,
Just control this.
save. There we go.
So
Yeah, Control S is a bit dangerous. If you do it down here, I'll show you that again. Warm. That's good. What about 100? Don't go outside. That's good. What about 30? Nothing. Shouldn't it say don't go outside?
the 30 degrees, it should say
Let me see. It's here, right? The program should print cool when the temperature is greater than 40 and less than or equal to 60. I think it does that. Should print warm when the temperature is greater than 60 and less than or equal to 85. I think it does that. And it should print don't go outside for all other temperature values. All other temperature values. So this does not express all other temperature values. That's why you would want to use else by itself, because that's all other values. You're narrowing it down. You're only taking all the other values that are greater than 85.
So should I just erase that and put else?
Exactly. That's all other values. Let's save it, compile it, and test it. That's it. Now it's working. All right, I hope that helped people. And Sheridan, thank you for doing this. It really helps a lot. Any other last minute questions before we break? Okay, and then that's, so that means don't forget to prepare for the quizzes. You know, the quizzes are coming up. The quiz for this, what is it? We had one quiz already in the Wednesday lab. So we won't have a quiz today. We'll have it next week. We'll have 2 quizzes on one day for assignments 2 and 3. All right? I have to look at the deadlines again to make sure I get those right. All right, that's it.